All right, guys, so we'll go ahead and get to it. 11.4, this will be the last new thing we cover all year. You'll have another optional Math Excel to go with this, and so here we go. So today is called conditional probability, so it's always, the probability of something given something else, okay? So it says, the formula is, the probability of event B given event A. So I would always suggest you kind of think about the given thing first, and that helps you with, we kind of look at these tables that we'll see in our examples. So I always kind of think about, this first. And that helps, okay? Because it's like I don't know, the verbiage in this can really be one little order of a word can change what they're asking for. So you really gotta focus on what you're asking for. Okay. Before we answer example 1 questions, we'll go ahead and complete the table. So we'll go ahead and add up all of our rows and columns and stuff and get our totals. So 2-year colleges totals is going to be 1866 plus 2452. That'd be 4318. 4-year colleges total would be 4324 plus 5517 to get 9841. And then so on and so forth. Grad school total 3301. And then you also want to total up your males and females, so totaling up the both columns there. So males 1866 plus 4324 plus 1349 should give you 7539. And females, if we add those up, that's 9921. All right, so now we will need those basically in all of our probabilities. Okay, so what we're being asked in A is what's the probability that if we're looking at grad school students that person is female. Okay, so again, I always think about this first. Given what? All right, given that we're looking at grad school. What's the probability that it's that person's female, right? So grad school total is what we want first. So grad school total, and then we're gonna put that over. Sorry, that's gonna be my denominator. So grad school total is my denominator, and then female grad school students is going to be my numerator. So female grad school. All right, so then you just pick them out, right? So my female grad school student number is looks like 1952. So that's my numerator, 1952. And then my denominator is the total number of grad school students, so 3,301. All right, then you just do 1,952 divided by 3,301, and we'll call that, you should see about 0.59 if you're typing that in, so about 59%. All right, so in the next one, we are looking at given that I'm looking at females here, so kind of thinking about that's my denominator here is 9,921. Given that I'm looking at females, what's the probability that female attended a 4-year college? So that number would be 5,517. So 5,517 females who attended college attended a 4-year college. Okay, so if we divide there, we get about 0.55, so about 55%. All right, and then given that in our last example, given that we're looking at 2-year colleges, right? So what's my denominator number for the next one going to be? Given that I'm looking at 2-year colleges, what would my denominator be as a number? Yeah, 4,318. And then if that's my denominator, what would my numerator be? 1866. That's right. So we want to do 1866 out of 4,318. So you guys are getting it. So that ends up being about 25%. All right. So I think that I don't really know why this is on here. So you can, I think, just mark this out, probability of independent events. I think that was a accidental copy paste because we don't really use that. We're just using the same thing the whole way through. So these questions are worded, yeah. Is that wrong? Let's see. It might be wrong. I'm just copying some pre-made notes, so we'll want to get that correct on the notes. So 1866. Oh, we did the wrong denominator. That's what we did, didn't we? Oh, on the notes they did the wrong. Yeah. So on the notes. Yeah, so on the notes, let's see. She set it up as, yeah, she did the wrong denominator on the, or I had the wrong denominator on the notes. So yeah, what would that be then? I had 7,539 as my denominator, which is wrong. So if we do use the right denominator, and thank you, Hayden, for catching that, we should get 4318. Should be about 43%. All right, so thank you again, sir, and I'll have to correct that on the notes for anybody who looks at them. All right, good catch. All right, and that's why we don't assume. Okay, so example 2 is going to be based on this table. We'll go ahead and total them out just so you have that, so you can focus more on just how to set them up and where to go from there. So if you want to just copy this down, our paper total is 83. Our metal total is 20.8. Our glass total is 13.6. Plastic is 30.7. Let's see, other is 68. And then our recycled total is 79.4. And our not recycled total is 136.7. So what I would like you to try to do over the next couple minutes, and you have like an A and then there is a B and a C on the back side, try to not only set up your fraction, but also try to use that same notation. So like try to write it out as probability of, blank and blank. So try to fill in that as well if you can. Okay. So take a couple minutes. Feel free to work with your partner, and based on the verbiage there, how would we use the same notation we did in the last one, and also what's the probability? And I'll go over them, like I said, in about 2.5 minutes. Hayden, here you go. Thanks for getting that correct. All right, guys. So just kind of compare like what you thought with kind of the key here, and then we can have a discussion if that's necessary. All right. So again, these are worded kind of more realistically. We're not using the notation, but I think if you try to use the notation based on the words, that'll help you understand it a little bit better. All right. So A says, looking at the table there, what's the probability that a sample of recycled waste is paper? So this would be given that we're looking at recycled waste. So given recycled, that waste is paper. Okay. So once we know that, then we're looking at recycled paper out of total recycled. Okay. So that would be 45.2 out of 79.4. And that ends up being around 57%. So we'll just kind of go one at a time here. Anybody have any questions about that now that I've shown it, or no? All right. So example B, what's the probability that a sample of plastic waste is recycled? Okay. So given we want given that it's plastic waste, that it's recycled plastic waste. Recycled plastic waste, given that we're looking at plastic waste. All right, so that would be, your numbers would be 2.1 out of 30.7. 2.1 out of 30.7, which is around 7%. Any questions on that one? All right. And the last one, what's the probability that a sample of not recycled waste, so given not recycled, that's glass? So what percentage of the not recycled waste is glass? Or if we want to put it in this notation, probability of not recycled glass, or sorry, not recycled, yeah, not recycled glass out of not recycled total waste is what you would do. So those numbers are going to be not recycled glass is up there 10.4, and then total would be 136, 136.7. So 10.4 out of 136.7. And that's about 8%. Okay, so anyways, now that you've tried a couple on your own, anybody having any questions, or is it kind of making sense? It's just kind of the order of the words and stuff, kind of understanding exactly what you're being asked. Little differences in words can make a difference, right? All right, so last one. Utility company asked 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays online given that customer is male? So based on what you see on the table, go ahead and try to answer that question, and I'll go over it in 30 seconds or so. And that'll be it. That's it. That's all. All right, so what we're looking for here is using the kind of the formula. We would be looking for the probability of a male who pays online, given that we're talking about males, okay, total males, right? So that ends up being 12 out of 20, right? So 12 plus 8 to get to 20, and that is exactly 60%. So there you go. There you have it. Hopefully this helps, and there you go. Let me know if you have any questions. Homework is optional, and that's it for 11.4.